welcome to this tutorial. In this tutorial, we are going to learn how we can use that Plaxis Alley Connect edition to analyze a simple 2D slope. This is going to be a beginner tutorial for the students who are studying the geotechnical engineering or who are doing the masters in geotechnical engineering, or the engineers who are concerned with the analysis of the soil slopes. So let's start. Plaxis Alley Connect Edition. It is the you can say the latest software right now in the Bentley industry. It is actually compromising of Plaxis 3D limit equilibrium software and the Plaxis Designer, which acts like a BIM software for all the geotechnical solutions. So right now I am having a student license here. So we are going to analyze this slope. You can see on your screen that there is a slope which is 10-meter high and it is a 20-meter at the base. It's having a side slope of as 1 in 2. The soil is kind of a clay. The cohesion is 25 kilonewton per meter square. And the phi is 10 degree here. That is the angle of internal friction is 10 degree. The unit weight of soil is here. That is 19 kilonewton per meter cube. We are going to use this soil properties and we are going to draw this slope in our into our software. And then we are going to see if this slope is going to be failed or it is going to get passed. Ultimately, we are going to check the factor of safety. That what is going to be the factor of safety? That is the activating moment. We are going to check how much is going to be the activating moment and how much is going to be the resistive moment. So this is going to be a basic tutorial to have you have an you can say walkthrough of the UI and how to use the tools. Okay, so let's start. So first of all, before starting, we need to draw this slope into our software, and our software usually works on the coordinates. So we need to first finalize the coordinates. Okay, so we are going to finalize the coordinates. Let's give this point the coordinate of 0, 0. Okay, suppose this is the x-axis and the vertical one is the y-axis. Okay, that we take it usually x and y. Vertical is going to be y. Then this point is going to be how much? This is 20 meters. So obviously it is going to be 20, 0 because we are not moving in y direction. So it is going to be 20, 0. And this third vertex is going to be what? It is going to be your 0, 10 because we are not moving in x direction. We are just moving in y direction. So these three coordinates need to be there. So let's start. We'll go to our Plaxis Alley Connect edition. I'll hit create a new model. Okay, I'm going to clear all these things up, the things that I have annotated. Okay, now I'll minimize this thing also. So now it is asking create new model. So I'm going to give my project a name. I'm going to give it name slope 01 just randomly. Okay, this is the by default place where this project is going to get saved. Now it is asking for the module, which module I want right now. I want slope stability. We can go for the Plaxis Designer and for the consolidation, groundwater analysis, dynamics also. I'm going to go for the slope stability. And right now the system I'm going to use is 2D. Okay. Then the units I'm going to take is metric. You can take it any other, that is imperial. You can take, that is feet and inches. I'm going to take metric. This is again what is going to be the slip direction. What is going to be the slip direction means if this slope is going to slip, what is going to be the direction? Obviously, we can see if this is going to slip, the slip is going to from the left to the right. So we need to take that care of. Okay. So it is going to be from left to right or left to right. Here we have to write the model name. I am going to write slope 001. Whatever name you want, you wish, you can type. I'll press OK. Now the 2D module of Plaxis will open up and we can now do the addition and you can say defining the geometry, defining the materials. Then we are going to solve it. Okay. So that Plaxis 3D is going to be open. In it is going to open the 2D, you can say module. Okay. So this is the 2D module. You can see this is the x direction. This is the y direction. Right now it is 1.10 meter long onto the x and y both. So first what we have to do, we have to define the region. Region means we have to define the geometry. Okay. So here onto the top, we have a geometry. Prior to that, there is a thing that is known as here the model. Onto the model, we can go into the settings and we can set all the project settings here. That is what is going to be the slip direction. The slip surface is going to be what, circular, composite, or what. If you are going to do the slope search method, how much you are going to generate the seeds. Okay. Similarly, calculation methods are there. Right now, it is by default on GLE. You can go for the Bishop simplified method or the Falanis ordinary method. Okay. You can uncheck any other. So what method you want, calculation method, you can do. Right now, I'm taking the ordinary and the Bishop simplified process. There are other options also. Please have a look over it and try to understand what all these things means. Okay, I'll just press OK right now here. We are going to click onto the geometry. Now here we have a bit of option. I'm going to draw region polygon, or you can also go for the import and export options. You can import a DXF file or the shape file and like that. I'm going to click on draw region polygon. Now, the moment I click it, it is going to ask me the coordinates. Right now, it is asking the two dynamic inputs. One is for X and other is for Y. So first coordinate is going to be 0, 0. So I'll write 0 and then I'll hit tab to move on to the Y coordinate. I'll again hit 0 and then I'll hit enter. Okay, so it will stick to the, you can say the 0, 0. The command is already now working. We are going to input the next coordinate. The next coordinate is going to be how much? It is going to be 20, tab 0, enter. Okay, now it is gone. It has gone out of the screen. So no need to worry about it. Just try to put in the coordinates and just move your mouse, the cursor, you will see that the command is still working. Now you can input the third unit. The third unit, third coordinate. The third coordinate is 0, tab 10. That is 0, 10. Okay, then I'll press enter. Okay, so now 3 of the coordinates has been done, but the command is still working. You can just right click somewhere on the empty area and you can click finish drawing. Now the moment you will click it, it is going to zoom extend and your all of the drawings is going to come out into the your screen. Okay, it is going to fit in the screen. If it is not going to fit in the screen by default, you can always go up here and there is an option zoom window, and onto that there is adjacent to it, there is zoom to extent. You can also zoom out and zoom it, all this. Okay, so if you're going to click on to left, if you are going to left click on this, you can say the geometry, it is going to say it is a region 1. The R1 name has been by default generated. You can right click on it and you can go onto the region property. You can also see the coordinates here. If you want to add another coordinates, you can easily do it here also by clicking insert. Right now, I'm not going to do anything. This is our slope. Now, let's go into the material. We need to define that what material is going to be applied onto this slope. Software need to know that what material is going to be there, which he needs to analyze. Okay, so I'll go to the material and there is a manager option. I'll go to the material manager. Right now it is empty. I'm going to click on new. Now here we need to give it a name. I'm going to give it name clay. Okay, because this is a clay. Then there is a method, that is what type of material you are defining. It's a soil drained more column, or it is going to be an anisotropic, it is going to be an undrained. Okay, is it a bedrock, or is it anything else? You can discover, you can explore these all the options. Right now I'm going to use with the more column, and you are going to give it a, you can give a color to it. Okay, so you can choose the color of your choice and you'll press OK. The moment you are going to press OK, they are going to be the shear strength properties here. You need to fill it up. That is how much the cohesion is going to be. It is in kilopascal. Okay, so it is asking kilopascal because I have chosen the units in metric. In other, you are going to ask like that. Okay, so cohesion, I was having the cohesion of that is 25. So I'm going to input 25 here. And the friction angle phi was, that is 10 degree. We can write 10 here. We can go on to the unit weight. The unit weight was 19 kilonewton per meter cube. So I'll keep as it is and I'll press OK. The moment I'll press OK, a material will get defined here. You can define more materials by clicking on new, and you can do it for many type of, you can say, material. I'll press OK here. Now we need to apply this material onto our this region. Okay, so there are plenty of methods by which you can apply material onto any region. First one is you can select the region, right click, you can go into the apply material and there is a clay, you can click on it, or you can go onto the region properties. Here we have a material, you can click clay here and you can press OK. Okay, so the clay has been applied here. So you can apply like that. Now almost everything is done. I'm going to save this. I'll hit save. And after material, we have slip circles also. You can define the slope limit, tension cracks, any. If you have any water table, you can do it. I will describe this function of this water table in the upcoming videos. Then you can define the loadings also. If there is a loading onto the slopes, you can apply that also. If there are any supports, if there are any connections you have defined, like you can see here, if I'm going to new, the support types include, that is anchored geotextiles thing, micropiles, soil nails. Okay, so you can define all those things. Right now I'm not using it. And on to last, we have solve. So our project our model has been almost created and the materials have been applied. The only thing which remain is the analysis part. I'll hit on analysis, I'll save and continue, and we'll wait for a few seconds. A pop-up will generate, and that pop-up will going to, you can say, the analyze it, and it is going to give you the factor of safety against the movement. According to the ordinary method, it is having 1.904 factor of safety method. According to Bishop's analysis, the factor of safety is 1.953. Okay, you can click on visualize result here, and the results will be onto the screen. You can see onto the left hand side there is a slope information. Here we are having a total activated moment of 4.14 multiplied by 10 to power 3 kilonewton meter, and the resisting moment is 7.889 multiplied by 10 to power 3. This E means the power to the power. Okay, so we can say it is actually very good. It is the resisting moment is 7.889 and the activating moment is 4.143. What is going to be the radius of the slip circle is 11.935. What is going to be the coordinate? It is 13.456, 12.009. So what is going to be the slip circle entry point and the exit point? These are entry and exit points. You can see the slip circle. You can see the factor of safety here. Okay, so these are the things. So now we have done these steps. So we are right now, you can say onto the left hand side, we are right now in the output mode. If you want to edit this slope, you can go again into this one that is open input and you can change the things up. Okay, so suppose I want to change these things. Suppose I want to change this slope. I want to make this slope a bit steeper and I want to check if this is going to be pass or not. So you can go into this again input method and you can click on this region, right click, you can go into the region property and you can change any coordinate here. Let's suppose I make this 0, 10, 0, 20. Okay, and I'll press OK. So you can see the slope has now been steeper. I have just stretched the slope a bit 10 meter upward. Now we are going to solve it again. Solve, analyze, save and continue. Now we'll check if this is going to fall, this is going to fail or not. Into the previous it was getting passed because the factor of safety was greater than 1. But now in this case you can see the factor of safety has been fallen down from the 1 and it is 0.929 and 0.921. You can go into the visualize result and you can see all the things. That this is going to be the failure slope. The factor of safety is 0.929. On to the bottom right, you can see the total resisting moment is 2.122, but the activating moment is greater than this, that is 2.283. So indeed it is going to have a fail. So I hope you have got an idea of how this Plaxis, you can say, is going to be used to analyze 2D slopes easily. You can make you can say you can build up the regions also from different materials. The slope can be of different shape and sizes also. It can be made up of, you can say, different type of soils also. And in the upcoming videos, I am going to analyze other type of, you can say, the slopes also. And we are going to see how this software is going to help us in analyzing the geotechnical problems. I hope you have enjoyed this video. If you have any question, please do ask me in the comments. Thank you.